So today is a problem. We have a binary tree. And we want to find the sum of binary numbers. The numbers is a 1 or 0 in each tree node. So to collect these numbers, we have to walk the array or binary tree deep down. This is a 1 0 0 1. This is a 1 0 1 1 0 1 and 1 0 0. Then we have to sum them up. The most obvious brute force approach is just you walking down the tree, you propagate the variable, and you do this like variable times 2 plus current value of node. And when you see the deepest node, it is when the left and right pointer both are null, or they can be equal with themselves. So this is how you can detect the last node, and then finally how you can propagate the sum back. You can use the global variable. So it is the easiest way, and I would recommend it to the interview. Just use global variable. But if you want to shine your skill, you can propagate it back. Just return the result as this sum. So let's look at my solution. This is how you detect this node, and I spent almost 8 minutes to write this code because I stuck with the final wrong solution, because you have to track what this x is actually is, because when you add the end node, you have to still shift x by one position left before adding the value. Or you can, instead of times 2 here, you can do times 2 here, and this still be accepted. And this is how it works. Just be consistent with what is x is actually is at each node. Now let's look at the Golfer solution. The first intuition for, oh, this is unfortunate, for the golf solution is that we want to avoid this if check, if left and right equals null. How can we avoid it? As we solving the recursion, we have to think from the result. And instead of looking at this equation, if left and right, imagine we don't check it at all, like this. Don't check. Now this sum would obviously be wrong, because it would never return the result. We only propagating the variable, but at the leaf endings we only return 0. Now let's keep this fact in mind. So this is as sum of left and right, and we know that at the leaves the s is 0, so We can write it like this: if s is 0, we is the end, so we should return x times 2 plus 1. So, and else we just propagating the sum top to the top. So, if we draw, we would see that in this case s equal 0, and this s is not equal 0, and we can propagate it to the part. So now this solution should work, obviously, if lit code would not fail again. Okay, it's already too slow. I probably didn't have internet. No, I have internet. Okay, it doesn't matter. So now how we can make it even shorter? When we're dealing with positive values, s equals 0 is the smallest value, so we can just make it like the maximum of this value and this sum. Now let's look at final. Oh, this is Java. This is old. Okay, nothing is working today, so okay, I will try to write it down. So the second shortcut is we can avoid argument. How can we avoid the extra argument to propagate? We can store in values itself. Without the code, it's almost impossible to do this from my memory. So I have to write it again. Like imagine we have a function and this is a root node. And without this extra argument, we can use the same maximum of value times 2, or not, yes, value times 2. So the value is the previous x, and this is just value. Now we can go f left plus f right, and this would be the solution. Okay, I think this is it for today, because I don't have internet, or it's something with a lit code. litcode.com. Okay, they have problems. It's fine. That's it for today.